morning, grade 9 math class. Today is Monday, March 7th, and we have another snow day. So today we're going to be looking at cycle 4, day 1 and 2. So our test was supposed to be today, but we're going to move it to tomorrow. So today we're going to be looking at cycle 4, day 1 and 2. Also, a couple of notes to make is that tomorrow is our non-uniform day, but it's a 2-N for non-uni to raise money for Ukraine. So wear your blue and yellow. Secondly, on Wednesday is another non-uniform day, but it is a green and silver day to celebrate and cheer on our basketball teams who are playing in the Memorial Cup. All right, so let's get started on cycle 4, day 1 and day 2. So for day 1, we are looking at linear relations. So back into looking at some lines. Here we're recognizing whether a linear relation is direct. You remember that word, direct, where it's going directly to the origin. We see the initial value where the start is starting right at the origin. Or partial variation, where we're partially up the graph to help us determine the equation. So here we have direct variation is in the form y equals mx, so we can see that there's no initial value, there's only a rate of change, where m is the rate of change, x's are whatever we're listing as our independent variable along the bottom, and y is our whatever we're going to list as our dependent variable. So here we have b is equal to 0, so initial value is nothing. Our initial value is 0. For partial variation, we are partially up the graph, and we can see that there's initial value here. Our initial value is b, and whatever the graph or the line is going up by is m. That represents like how much we're increasing by. All right, so here we have an example where Dasha is flying from Hamilton to Orlando, Florida for a vacation. Dasha's luggage must weigh less than 50 pounds. She knows that her luggage weighs 33 kilograms. Is her luggage too heavy? All right, we have a chart that's happening here. For 0 pounds, it's 0 kilograms. So automatically here, we can see it's direct variation because it starts at 0, 0. Then for every 1 pound, it's 0.45. 2 pounds, 0.90. 3 pounds, it just keeps on going up by 0.45 each time. All right, so what we're trying to determine here is if we go up to 33, how many pounds is that? All right, this looks a lot like our last unit with conversions. So here we have our conversion. For every 1 pound, we get 0.45 kilograms. So 1 pound, so 1 lb, we get 0.45 kilograms, kg. All right, that's equal to, okay, where does that 33? We don't need the 50, we just know that it has to be less than 50. 33 goes here, because it's also kg, so kgs are all along the bottom. And how many pounds is that? So cross, multiply, divide. So we're going to do 33 times 1 divided by 0.45. Okay, let's go check that on our Desmos calculator. 33, not times 0.45, divided times 1. So we're going to times 1, which is 33, and then divide it by 0.45. All right, we get 73.33. All right, so this equals 73.33. And what's that represent? Yeah, right here. This is 73.33 pounds. So will she be allowed to put her luggage on the plane? Nope, this is when it's too heavy. Yeah, so no, it is too heavy. So Dasha's luggage is too heavy for the plane. All right, you can even specify like this 73.33 is greater than 50 pounds. There we go. All right, another example. The relationship between Fahrenheit scale and Celsius is modeled by this equation. So we have C equals 5 divided by 9 bracket F minus, or Fahrenheit minus 32, where C is the temperature on the Celsius scale and F is the temperature on the Fahrenheit scale. All right, so we're going to complete the following and round your answer to the nearest degree. Okay, so if we know F is -10, this is Fahrenheit's -10, what's Celsius? So that means C is equal to, let's just write down our formula, not 5/9 bracket, and then where we see F, we're going to write -10. Okay, let's put -10 right here. So -10 minus 32. All right, we got this. Let's do what's in the brackets. What's -10 minus 32? And we're going to multiply that by 5/9. Okay, so we're going more into the negatives. How much more? 10 more into the negatives. So we're at -42. Right? We can even double check that. -10 minus 32 is going to give us -42. And what's great about our Desmos calculator is I can do 5 divided by 9 and then actually put our -10 minus 32 right here. And I get the answer. I get -23.3. Okay, I'm going to go write that down. This is -23.3. So if it's -23.3 degrees Celsius outside, that means it's -10 Fahrenheit. All right. What's beautiful about this Desmos calculator is I can just go change the next one. The next one is 0, and I need to put it in for F. So there we go. We're going to get it right here. 5 divided by 9 bracket 0 minus 32, and it changes automatically. I didn't have to retype it out. It's beautiful. All right. So C is equal to 5/9. Again, here we're going to put 0 this time in for F and minus 32 to give us, I have it right here, -17.77. So -17.8. All right, let's keep on going. What if we had 32? So again, we can see that F is now going to be 32. So instead of writing F, we write 32. What's 32 minus 32? Yeah, it's 0. And 0 times a number, that's just going to give us 0. If you see 0 degrees Celsius, that means it's 32 degrees Fahrenheit. Let's just keep on going. 5/9, 5/9, 5/9. And then what's this number this time? 68. What about this one? This is going to be 100. And then this one's 212. Right, let's go calculate all those by changing just one number. Right, I'm going to change that 0 to a 68. Okay, we get 20. What about, it's 100 degrees Fahrenheit. What's the temperature? Ooh, that's hot. 37.8. What if it's 212? Oh, boiling 100 degrees Celsius. That's a boiling point. So obviously not outside, an outside temperature, but definitely a temperature on top of a stove. All right, complete the handout, and if you have any questions, let me know.